minus 11x squared plus 3x plus 12. And now the fun begins, all right?
Yay.
Yay! So we go through and think what times what? This, what times this gives me x to the fourth. So I get an x cubed. I get x to the fourth minus 5x cubed. I'm going to change the signs. So this cancels because it's opposed to, and this is going to give me 2x cubed minus 11x squared. And then I think, well, what times this gives me 2x squared cubed, so plus 2x squared. So I end up with 2x cubed minus 10x squared. Change the signs because I'm subtracting. This cancels. So I get negative x squared plus 3x.
This is known as the program.
And then I think what goes here, so that this times this gives me negative x squared, so negative x. I get negative x squared plus 5x. And change the signs, so that cancels. That gives me negative 2x plus 12. And, well, I need a minus 2. So I get negative 2x plus 10. And when I change the signs, this cancels, and that's going to give me a remainder of 2.
Oh. You're so close.
Which puts a plus 2 over x minus 5, and there's your answer. So, did you notice this was kind of, when you did your homework, that it was kind of a repetitive process?
Very.
It's like the same thing over and over, right? All right. And so what we're going to do today is talk about how can we streamline this. Like, we're only going to write down what's absolutely necessary. So right now I'm going to talk about what's necessary and, more importantly, what's not necessary. So the first thing that I'm going to talk about that's not really necessary is, you know, I've got this x to the fourth, this x cubed, this x, and this, you know, the x squared and the x. And it turns out the x's aren't necessary in this procedure. See, because what's really important in all this is the number in front. Like, I almost think of this as, like when you're doing the long division, you have like your thousands place, your hundreds place. I think of this as like the x to the fourth place. So how many x to the fourth I have is more important than the actual x to the fourth. How many x cubes do I have is more important than the x cubed, right? So when I'm looking at this, I'm thinking, okay, well, the numbers that are important, I mean, the x's aren't important, but the numbers are. So I'm going to write down the numbers. Right? So I'm going to write down the numbers. I'm going to write down a 1, a negative 3, a negative 11, a 3, and a 12. All right? Next, and this is the part that's, like when I was in school, it didn't make a whole, I mean, as I've taught longer, it makes more sense. But if you're just analyzing this, you did this times this to write it here, and then it got canceled, didn't it?
Yes.
And then you did this times this to put here, and then it got canceled, didn't it? And then you did something, you got canceled. Well, why are we writing it down if we know what's going to cancel? Because, I mean, it has to cancel each time, so if it's got to cancel, why bother writing it down? See, when I look at this, what's really important isn't this thing. Turns out what's important is this little computation where I say this plus this equals this. And then, you know, I say something like this plus this equals this. I say something like this plus this equals this. And I say something like this plus this. It turns out sort of the most important computation in this whole procedure are these 4 arithmetic problems. And so this doesn't matter, this doesn't matter. Well, you know, if this doesn't matter, you know, what gives us this term is this x. Well, if this doesn't matter, that means this doesn't matter. So if I look and I think, well, what really matters on this outside, like the only thing that matters on inside this little house thing are the coefficients, and what matters on the outside is really that 5. Because this x creates something that doesn't matter, so it's creates something that doesn't matter, I don't care about it. So I'm going to put the 5 in. I mean, technically, I guess I should put a -5, right? But, you know, notice how we put something down and then we instantly change the sign? Notice like we put everything here and then we change the sign? Why don't we just change the sign before, so instead of having a -5, we have a +5? And so what I'd like everybody to do on your notebook paper somewhere is I want you to write the 1, -3, -11, 3, 12, and then put a 5 in a little box or like half a box. Okay, has everybody done that?
Yes.
And then I want you to skip a line, because we're actually going to put some numbers here. And I want you to draw a line and leave room so you can actually put numbers here. So for most of you, that'll probably be like you've written this on one line of notebook, skip a line, and then draw a line. All right? Okay, everybody done that part? Okay, so here's what we're going to do. Take that first number and just drop it down below the line. We'll see why in a minute. But right now, I just want to take that first number and drop it below the line. And now, we're going to do this times this and stick the number here. So 5 times 1, I'm going to stick the number here, and that's a 5. And then we're going to add. So this plus this, that gives me a 2. Now we're going to do it again. This times this, stick the number here. So 5 times 2 is 10. I'll put the number here. And then we're going to add, which gives us a -1. And then we're going to say this times this and stick the number here. So 5 times -1 gives me a -5. Then we're going to add, which is going to give me a -2. And then we're going to do this times this and stick the number here. So 5 times -2 gives me a -10. And when I add, I get a 2 over here. And normally textbooks put like a line here or some dash line. Remember I talked about here, I said the most important part of this whole procedure was the -3 plus 5 equals 2. And the -11 plus 10 equals -1. And the 3 minus 5 is -2. And the 12 minus 10 is 2.
Yo.
That's cool.
Right? So, I mean, this has got a special name. This is called, whoops, there's an N in there. Synthetic.
Synthetic division.
Synthetic division. Now, the thing I want you to remember about synthetic division is it's really this. They just cut out all the extra stuff. Right? What somebody did is they looked at it and they said, I'm writing down some things I don't really need to. And if you cut out all the extra stuff, you're left with synthetic division. Right? Takes up a lot less room, doesn't it?
It's more fun the other way.
Yes, it is, yeah.
I have a question. Why did you use 5 instead of -5?
So my answer to that question is actually going to change in the next 10 minutes. But right now, right, it was, remember remember how we had to change the sign here?
Yeah.
So why not change the sign up here,
Okay.
and then then you can just add as opposed to subtracting each time. Yes.
So if it was x plus 5, would it be
You
changed
to a -5, right? Now, this obviously is not your answer because your answer should involve some x's, shouldn't it? Right? I mean, we just can't have numbers, right? We have to have x's. So in synthetic division, like this gives us the coefficients. And since we started with a degree 4, after you do synthetic division, you're going to end with a degree 3. So to write my final answer, I'm going to write this down as x cubed plus 2x squared minus x minus 2. Guess what the 2 is?
The remainder.
The remainder, so I'll have to put plus 2 over x minus 5.
Wait,
That's right.
All right. Now, personal note. When I was first presented this in Algebra 2, I didn't like it because I actually like long division. And so when I was ever given a choice, I did long division because I understood long division. Right? This to me was almost magic. Like you just do a random procedure and you hope the answer comes out right. Right? And I always I never trusted magic. Right? So I always did long division. And it wasn't until I started teaching that I thought, well, why do you do synthetic division this way? And I thought about it and said, oh, it's really just long division that somebody cut out all the extra stuff. Yes?
Does the synthetic division work with the last thing we did, like x2 minus 2?
That is an awesome question. No. And I'm going to address that at the end of class. But that is a great question. I like how you were trying to connect that. Well, it can. It's not pretty, and I'll talk about why that is in a little bit. All right. So that's synthetic division. So your turn.
No, maybe not.
Well, let's say I give you 3x cubed minus 4x squared plus 2x minus 1 divided by x plus 1. All right. All right.
I'm nervous that it's wrong, so I don't want to.
It's okay. All right. So, well, as far as synthetic division goes, we have to put these numbers. So 3, negative 4, 2, negative 1. What's going to go in the box?
Negative 1.
Negative
I
1.
said first.
Right? Because we have to change the sign, right?
It's already a positive 1. It's negative 1.
Oh, negative 1.
Yeah.
Thank you.
Yeah,
Okay.
I said first.
And we bring the 3 down. This times this gives me a negative 3. Going to give me a negative 7. This times this gives me an 8. How about a 7?
An 8.
Just kidding. Just kidding. Okay. This time this gives me, making sure y'all paying attention. Good job. Okay. Add together to get a 9. This times this gives you negative 9. You add together to get a negative 10.
Yes.
That's our remainder.
Yes. It's
Right.
over, our remaider's over x plus 1.
Yeah.
But well, let's get the rest of it, right?
We still have to do the x's.
We still have to put the x's since it started with x cubed.
It's going to be an x.
So 3x squared minus 7x plus 9 minus
Minus 10 over x plus 1.
10 over x plus 1, and there's our answer.
I got it.
Yay.
That's so cool. I didn't even like it.
So we just drop down the 3, we don't multiply by negative 1?
What?
We just drop down the first 3, we don't.
Yeah, you don't, right. That's, whenever you're doing synthetic division, the first number always drops down.
Okay.
A very common mistake is students try to do something to that first number. You just bring the first one down.
Okay.
Yeah.
All right, so what if I give you x cubed minus 5x plus
Sorry, guys.
2 divided by x
Yeah.
plus 3?
Oh, okay.
So, sorry, I have to repeat myself again. You needed a placeholder. Okay.
Wait. Can you say one more time why you need a placeholder?
No.
So in long division, thank you for helping me. It's okay. In long division, we needed to have like every position. We had, if we started with x cubed, we needed to have an x squared, an x, and a number. Well, since this is the same thing as long division, we need a placeholder. We need an x cubed, an x squared, an x. And since it didn't have an x squared, we have to put a 0 in. Right? So I'm going to bring the 1 down. This times this gives me negative 3. And this times this gives me a 9.
I'm too smart for
It's
this.
going to give me 4. This times this gives me a negative 12.
Yeah, I am.
And so I end up with a remainder of negative 10. And my answer is going to be, since this was x cubed, then my next part is going to be x squared minus 3x plus 4 has a remainder of negative 10, so I get minus 10 over x plus 3. This makes sense.
Yes.
Yes.
Okay. And I mean, this procedure, and this is just a procedure. This is a skill that we are going to need to answer the questions I'm going to ask next week.
Okay.
All right?
Okay.
So, what about this one?
Uh-oh.
I don't know. I don't think I want to know. Yeah. True story.
Nobody says what about this one? screens. I don't know how that-
Wow, what a big problem. Wait, what's wrong with that?
Not synthetic.
Yes,
How about not much, right? It looks the same as the other one, doesn't it? Right? Right, like what is wrong with
Wait,
that?
no, wait.
You've got a coefficient on the first one.
Well, so let's set it up, all right? Well, let's see how we set this
Yeah,
up.
okay.
So the first thing I'm gonna do is put my coefficients up here, so I get a 4x, I get a 4, a -6, a 4, and a -1. That's the same thing we've done in the previous problems. The question is, what happens here? Okay? And so you might think, well, what would be a reasonable guess of what goes there?
1.
You could.
Oh, you think 1, right? Because that's what the other ones did, right?
No.
Okay,
-2.
but okay, but now we have to. I'm going to address why there's a -3 here. When I first started this process, I said, all right, there's a -3 because you changed the number, and that gets you the right answer, which is where I wanted you to be at the first few examples. But it's not quite mathematically correct. See, the reason there's a -3 here is -3 is what makes this 0. So when you're dividing by something, what you're interested in is what value of x makes this 0. Well, how you find that out is actually really easy. What you do is you take, in math, anytime you want something to equal 0, you literally just say, well, if I'm going to set x plus 3, I want to set it equal to 0, and if I solve, that's what makes it 0, isn't it?
Yeah.
So if I want to know what makes this 0, what?
1/2.
Well, yeah, 1/2, right? Take that and set it equal to 0. So if I set 2x minus 1 and set it equal to 0, then I get a 1/2.
Well, I don't like this fraction.
Okay.
Okay, whoa, give me a moment.
You still put the sign?
Well, what makes it 0 when you solve?
No, you don't put this.
Fractions are lame.
It's half.
See, because you move it over. Just like here, when you move the 3 over, you got a -3. When you're solving, it switches the sign. Okay? All right, so before we start this problem,
What in the heck?
okay, there might be a lot of people that are a little hesitant whenever you see a fraction. Now, I'm going to talk about, I need to talk about fractions for just a little bit. I constantly hear the phrase, I hate fractions. And my claim is, no, you don't hate fractions. You hate adding fractions where you have to get a common denominator.
No, I just
Okay.
like fractions.
Because honestly, as far as multiplying fractions, most people don't hate that at all. Multiplying fractions, like if I say what's 1/2 times 4, you don't have an issue with that, right? If I say what's 2/5 plus 5/5, you don't have an issue with that when the denominators are the same. What most people hate about fractions is not all of fractions, it's just adding when you have to get a common denominator. And, this is my guarantee, that won't happen. When you're doing synthetic division with a fraction, you will never have to get a common denominator.
What if it was a Gaussian grid?
Yeah, I won't give you any problems that I give you, nothing would happen. You will not get a common denominator. So, now we still go through this, all right? So when this goes through, what do? Well, we bring the 4 down. All right, 1/2 times 4, what's that going to give me? 2. When I add this, I get -4. Well, what's 1/2 times -4?
-2.
Add that gives me 2. What's that going to give me?
1.
1. So in this whole process, did I have to get a common denominator?
No.
Was having a fraction here that bad?
Yes.
No, having the fraction here wasn't terrible, right? So, are you going to have fractions with synthetic division? Yes. Okay? Is it going to be as bad as you think it is? No. All right? Because if we can just get through this fact that the issue with fractions is getting a common denominator, right? If you don't have to get a common denominator, there's usually not a problem. I didn't have to get a common denominator once. Right? So now what's my answer? Okay?
It's a 4x squared and then minus
4x squared minus 4x
plus 2.
plus 2, and I had a 0 remainder. And
I'll get it.
I'm waving my hands here because this is being recorded. Technically, that's not there's something else we need to do, but we're not going to today, because I just want to talk about, right?
What is it?
I said I'm not going to talk about it today.
Oh, I didn't know you were
Okay.
going to talk about it at all.
No. We will talk about it, just not today.
I was really curious. I don't want to leave my problem unfinished.
Yeah. All right, your turn. So what if I give you 4x to the 4th minus 15x cubed minus 28x squared
I do.
minus 6x plus
Whoa.
3
That's too many numbers.
divided by
Too many coefficients.
4x plus 1.
Funny, Grant, funny.
So I'm going to put negative 1/4,
Oh, wait.
and then there's a 4, negative 15.
Why is it a negative?
Because you have to decide.
This side.
Oh, we didn't. Oh.
No, set it equal to
You gotta
0.
set
Oh, sorry, my bad, yeah.
Negative 6.
Let's be nice.
Okay.
Hey.
I'll bring the 4 down. This times this is negative 1. That's going to give me a negative 16. This times this gives me 4. Get negative 24. This times this gives me a 6. 0. And then 1/4 times 0 gives me 0. And then,
Cool.
and so we get a remainder of 3. Did I mess? Yeah, I did mess up. And so how do we write our answer down? So let's do 4x cubed minus 16x squared minus 24x and a 0, right?
Yeah.
And then we end up with 3 over,
4x plus 1.
4x plus 1.
Well.
no.
That's how, why not?
Okay.
Alright.
So this is kind of related to where there's actually a lot more going on here that I've let on. I really just wanted to go through the procedure here. Technically what's happened is if this is in the box, what has to go here is x minus this. So what has to go here is x minus negative 1/4, which is x plus 1/4. Right? All right. That's what has to go there. Now, unfortunately, we can't leave our answer like this.
Yeah, we can.
No.
Oh, you just.
No, I don't like layered fractions. How we clean this up is actually, it's not hard. I promise it's not hard. You just have to understand what you can do.
Okay.
So if you have 3 over x plus 1/4. I never want layered fractions, and what makes a fraction is the denominator. So when I look at this, my issue here isn't the 1/4, my issue is just that 4. And if I could somehow just get rid of that 4, then I have something that looks normal. Right? Now, whenever you have a fraction, you are allowed to multiply the top and the bottom by the same thing. So what I'm going to do is multiply the top and bottom by 4. And when I multiply the top by 4, well, that's nice. That just gives me a 12.
4.
And look what happens when I multiply the bottom. Well, what's 4 times 1/4?
1, 6.
And what's 4 times x? 4x. And so when I distribute the 4, that gives me 4x plus 1. And so that ends up being my remainder.
So we could.
Okay, this was fun at first, it's not funny.
You need to make it fun.
No, we're
It's too much now.
So can you just
I'm not
multiply
this high
whatever
level.
else